Hi you guys, welcome to the stoichiometry unit. We are going to start talking about stoichiometry and how to do chemistry math. But before I do, I'm going to go over a really quick review of moles using molar mass. Okay, so you'll need your periodic table and a calculator. Okay, let's get started. So this should all be a review, but real quick, how many moles are present in 45 grams of lithium? This is what you're looking for. This is what you are given. Always start your dimensional analysis off with what you are given. So in this case, we're given 45 grams of lithium. And we want to convert this into moles. So realize that you are using your periodic table, and you're going to be using the molar mass of this. So find lithium in your periodic table. Lithium's right here. The mass of lithium is 6.94 grams per mole. Okay. So since we want to cancel grams out, you're going to put at the bottom right here 6.94 grams of lithium and 1 mole of lithium right here. Grams should cancel out, they're diagonal, and you are left with moles. Use your calculator. So it is now 45 divided by 6.94, which gives you your answer. Don't forget, in your given, you are given two significant figures, so your answer should also have 2 significant figures. So it is going to be 6.5 moles of lithium. Okay? The next one is done the same way. How many moles are present in 205 grams of carbon? This is what is given to you. This is what you need to find. Always start your dimensional analysis off with what you were given. 205 grams of carbon. Now, using your periodic table, right here is carbon, and it is 12.01 grams per mole. So 12.01 grams of carbon for every 1 mole of carbon. Again, put it in your calculator. 205 divided by 12.01, and you are left with, you have 3 significant figures and you're given, so your answer is also going to have 3 significant figures. In this case, it is 17.1. So realize the answer is 17.0669, but you have 3 significant figures. You're going to use that 6 to round it up to a 1. So it's going to be 17.1 moles of carbon. Okay, so the last two are going the other way now. How many grams are present in 2.85 moles of sodium phosphate? So you are given, you need to find grams, and you are given the moles of sodium phosphate. So it's 2.85 moles of sodium phosphate. Always start off with what you are given. Okay? Since you want to cancel moles is going to go down here, so it's going to be 1 mole of sodium phosphate. And in this case, this is a compound. All the others that we did, the problems before, were single elements, so we were able to use the mass from the periodic table. But now we need to find the molar mass of the compound. And that would be true here also. If either one of these were compounds, you would need to find the molar mass of it. So you have sodium, 3 phosphate. So you're going to use your periodic table. The mass of sodium in this case is 22.99. The mass of, right here, phosphorus is 30.97, and the mass of oxygen is 16. So we're going to use those 3 masses of the 3 elements. Okay. So this is 22.99 plus phosphorus is 1 times 30.97, 4 times 16, and you should be able to see it. Okay. So when you add all this up, put it in your calculator, and always try to get up to 2 decimal points for your mass, okay? I want to show you what I'm doing. So you just want 2 significant figures, and your molar mass is never used to figure out the significant figures for the problem. You always use what is given to you in the problem, your experimental value for your significant figures. Okay? So now you're just going to simply multiply the top, divide by the bottom. In this case it's just 1, so it really doesn't make a difference. Okay, and what you were given has a total of 3 significant figures, so your answer is also going to have 3 significant figures. In this case, it is going to be 0.0174. These zeros in the front do not matter, so you're going to disregard them, and it's 3 significant figures, and it is grams for sodium phosphate. The last one's water. It says how many grams, that's what you were trying to find, are present in 7.14 moles of water, which is what you were given. So we're going to go ahead and find the molar mass of water right here, and that is 2 hydrogens, 1.1 plus 1 oxygen, 16.00. It's going to equal 18.02 grams per mole. So start off with what you were given, 1.414 moles of water. You don't want your answer to be in moles, you want your answer to be in grams. So you're going to put 1 mole down here, 1 mole of H2O, and 18.02 grams of H2O on top. Okay, and when you multiply this, 7.14 times 18.02, you will get this as your answer. Remember, you have 1, 2, 3, 4 significant figures, so your answer is going to also 1, 2, 3 significant figures, so your answer is also going to have 3 significant figures. So your answer is 129 grams of water, H2O. Okay? Okay, so I want to talk to you about a new concept that you're going to be using in stoichiometry a lot, and that concept is mole-to-mole ratio. So where that mole-to-mole ratio comes in is that you are actually comparing the coefficient of your balanced equation to one another. So you were comparing the coefficient of the hydrogen gas to the oxygen gas to the liquid water. And so we can actually have a comparison of water, H2O, of hydrogen to oxygen, which would be 2 to 1. That's a ratio. It is a comparison. You're only comparing the coefficients of it. You can even go from H2O to hydrogen gas. And remember that the H2O has a 2 in front. So you're comparing the coefficient 2 to the coefficient 2 right here for water. Notice that this is 2 to 2. Usually when we're talking about fractions or something you reduce, but when we're talking about mole-to-mole ratios, never reduce. Keep it as it is. So this would be a mole-to-mole ratio of 2 to 2. Okay? Same way we can do oxygen to water. And it'd be 1 to 2. Oxygen to H2O, which would be 1 to 2. And it doesn't make a difference. Because this is a comparison, we can even flip it around any way we want. And we can do, this is H2 to oxygen, and over here I've done O2, the oxygen to hydrogen gas. So I flipped it here where it's oxygen gas, hydrogen gas, and this is hydrogen gas to oxygen. It doesn't make a difference. You can flip these around any way you want. Over here we could do water to oxygen gas. Let's do a little bit more of a complicated equation. You're doing the mole to mole ratio. Keep in mind that the mole to mole ratio is only done on you're only comparing two compounds to one another, or two ratios. So this would be, even though there isn't a number, it is still considered one. So we can do a mole to mole ratio of propane to oxygen. That'd be 1 to 5. We could also do propane to carbon dioxide. That'd be 1 to 3. Now we could do water to propane. It doesn't make a difference. I flipped it around, and it is now 4 to 1. Okay? So it really doesn't make a difference. Over here I flipped it around. I could do it for anything. I can even compare these two, the carbon dioxide to water. And this would be a 3 to 4 comparison. So as long I can compare within the same side of the arrow, or I can go from one side of the arrow to the other, or go the opposite way, it really does not make a difference. So in this case, I could just do H2O compared to oxygen gas, and that would be a 4 to 5 ratio. Okay? I could even do carbon dioxide to, let's do to oxygen gas, and that would be a 3 to 5 ratio. It doesn't make a difference. I could also do carbon dioxide to methane, and this would be a 3 to 1. Notice over here, I did it one way. Here, I did it the other way. It doesn't make a difference at all. So this is called mole to mole ratios, and we will be using this concept a lot when we do stoichiometry problems. So you really need to become familiar with it. Keep in mind that you're just comparing the coefficients of your balanced equation to one another. And you only compare two coefficients, and you never reduce. Okay? Never reduce. All right. Hope this helps you. Bye.